More Frequently Asked Questions webinar. Hi, my name is Drew and I'm the Didger Product Manager. I've been with Golden Software for almost 6 years. I'm here today to take an in-depth look at some of the most frequently asked questions about Didger 5. For those of you who remember, we covered some FAQs for Didger 5 in a webinar back in March. The webinar today will be covering some of the topics that did not get covered then. Today I'll be reviewing how to digitize a well log and export it to LAS format, how to recalibrate a project that has both vector and raster data in it, how to convert an image of a contour map to a grid and contour map in Surfer, and how to edit shapefiles in Didger. After the discussion of each topic, I will stop for a few minutes to answer any questions. You can send your questions to the webinar host via the questions function at any time. There is a question box on the webinar control panel under the audio section. Type in your question and it will be sent to the webinar host, who will then forward it to me. If your control panel is minimized, click the View menu and uncheck Auto Hide the Control Panel. This webinar will also be recorded, so after the webinar is finished, a video will be available on our website at goldensoftware.com. Alright, ladies and gents, let's get started. The first topic I would like to talk about today is vectorizing or digitizing well logs in Didger and exporting the digitized curve to LAS format. Didger offers two different approaches when digitizing well logs. First, after a well log image, which is usually in TIFF format or JPEG format, is imported and calibrated, Didger can automatically vectorize the log curves if there is enough contrast between the curve and the background grid, or if the curve is a different color than the background grid. If there's not enough contrast or color difference, as we see with historical black and white logs, you can use the second approach of manually digitizing the curve by using tools found in the Draw menu. I will be addressing the first approach today. Here are the steps. The first step in automatically vectorizing a well log is to import the log by using the File Import command. When the import dialog opens, I'm going to select the curve and click Open. In the Image Registration Warping dialog, I need to click some calibration points within the image, so I'm going to go ahead and zoom into the image using the zoom tool. This can also be done using the mouse wheel. As you can see at the top of the log, we have our X scale, and then along the sides we have our Y scale. This is very typical of any log. I'm going to zoom in close enough to where I can enter calibration points. So now that I'm zoomed in enough, and with the first point selected in the calibration table, I'm going to use the calibration marker tool and click within the image and add a few calibration points. In the reference X and the reference Y section, I'm going to go ahead and add the correct coordinates. Now that I have these two coordinates entered, I'm going to go ahead and pan down to a lower spot in the image by using the pan tool. And with the third line selected in the calibration table, again I'm going to use the calibration marker tool and insert two more calibration points. And I'm going to repeat the process of entering the coordinates here. Now that I have all the calibration points entered, I'm going to go ahead and click OK to calibrate the image. Great. Now that you can see the image has been calibrated, I'm going to go ahead and check by using the coordinates found down here in the status bar. I'm going to kind of mouse over the image to make sure that we got this calibrated correctly. As you can see, at a quick glance, this looks pretty good. So now the image has been imported and calibrated, we can use Didger's automatic vectorizing feature to digitize the curve. I'm going to click the image in the plot window to make sure it's selected. Then I'm going to use Image, Vectorize Image. You see the Vectorize Image dialog now open. I'm going to select Selected Colors. And with my mouse, I'm going to mouse over the image, and as you can see, my mouse pointer has changed to a selector, and I'm going to click on the curve somewhere to pick up the color. Now you can see in the Vectorize Image dialog that the color has populated this field. To deal with variation within the color of the log, I'm going to go ahead and increase the color tolerance a little bit before I click OK. And then everything looks like it's set, so I'm going to go ahead and click OK and let Didger vectorize this curve. Great, so you can see if I toggle the image off and on that you can see that the curve was automatically vectorized. Now, before I export this to LAS format, I want to go ahead and clean up the curve just a little bit because I see a few artifacts. For example, right here. Zoom in a little bit so I can get these. One more right here. All right, so now it looks like I can have all the artifacts cleaned up. And again, before I export, I want to go ahead and connect all these polyline segments. So I'm going to go ahead and select them all in the Data Manager. And I'm going to use Draw, Edit Boundaries, and Connect Polylines. Great, as you can see now, I've got one polyline that represents the curve, and I'm ready for export. To do so, I'm going to use File, Export. In the Export dialog, I'm going to name the file. And change the Save As type to LAS. And click Save. Now we see the LAS Export dialog. I'm going to enter the correct information for starting depth, ending depth, and the step value. If I select the Well Info tab of this dialog, other information can be entered here. Company name, well, date, API, lat long, and any information that I enter in here would be populated in the LAS file in the header information. So now that I have this important information set, I'm going to go ahead and click OK to export the LAS file. Okay, so now that I've vectorized the well curve and went through the steps, I wanted to open it up now for any questions from the audience to see if anybody has any questions what I've covered so far. Okay, I have a question coming in from my webinar host that says, can you show me the LAS format? Absolutely. Let's see here. What I'm going to do is open it up in a text editor, and I'll show the text editor here. And you can see right here that per the step value, which was 5, exported all the X and Y information for the curve. I have another question that came in that says, what can you do if the color varies? And I'm assuming you're meaning the color within the curve. Good question. When I set the color tolerance, I bumped it up just a little bit. There's a lot of variation within the curve. You might want to try to bump this up a little bit higher than I did. And this should account for any of the color variation you see within that well log image. I'm going to go ahead and check with my host here. Do we have any other questions? Okay, doesn't look like it. So it doesn't look like there are any more questions, so I'm going to move on to the next discussion topic for today, which is how to recalibrate a project that has both vector and raster data in it. So I'm going to open up a new file here. So as you've seen already today, the calibration process for an image is quick and easy and very straightforward. However, when vector or drawn objects are added to a project, the image registration warping command is no longer available and doesn't apply to the project. If I select the image like I did earlier and use image registration warping, you can see that it's grayed out. This is because there's the drawn curve already within this project. So to recalibrate a project that contains both types of objects can be done using Didger's coordinate conversion command. So for example, let's say you digitized a well log curve, similar to what we just did, and realized that you entered the wrong calibration coordinates during the calibration process. This can be easily corrected by using the map coordinate conversion command. I'm going to zoom into my image here just a little bit, real quick. Again, I'm going to use the map coordinate conversion command. When the coordinate conversion dialog opens, I'm going to make sure the input data units are set to meters. I'm also going to select georeference. We need to have 4 calibration points to recalibrate this project, so I'm going to go ahead and click the Add button 3 times. So you can see that we have 4 points in the calibration table now. I'm going to go ahead and select the first row here, and when I mouse over the image, you can see that my mouse pointer turns into a crosshair. This will allow me to insert calibration points into the image. So I'm going to go ahead and click here and add another calibration point right here, and then enter the correct real-world coordinates here. And I'm going to repeat that process for 2 more calibration points. And again, enter the correct coordinates under the world X and world Y boxes here. Okay. And before I click OK, I'm going to make sure the georeference method is set to a fine polynomial, and then I'll go ahead and click OK to recalibrate this project. Alright, so let's check the calibration here real quick. I'm going to do the same quick test I did just a second ago, where I'm going to look at the coordinates right down here in the status bar as I mouse over the image. And it looks like, from a quick glance, that we're pretty close. So as you can see, this is a quick, very quick and painless process. And now all the coordinates for the objects, both the raster and vector objects, have been converted to the desired coordinates. And so once again, I'm going to go ahead and open it up for any questions. So I'm going to talk to my host here. Do we have any questions? Okay, I have a question that came in that said, I noticed you were only using 4 calibration points. What is the required number in Didger? Technically speaking, that's a great question. Technically speaking, Didger requires a minimum of 3 calibration points. Since this image was, it's so clear with the underlying grid, I went ahead and added 4. When I moused over and kind of verified the calibration, if it seemed off, I could go back and add additional calibration points. You're going to find the more calibration points typically that you add, the more accurate the recalibration process is going to be. Okay, I have another question. Can you recalibrate a project that is in a projected coordinate system? Sure, absolutely. This example was a well-log curve because that's what I was dealing with, in the previous section here. However, the same process applies to any project type. So that could be a georeferenced image where there's, like in a mapping context, where there's some drawn objects and maybe some digitized roads or something like that. The same process can be used to either shift over the objects or to recalibrate the entire project, maybe if mistakes were made, at the original calibration. So it doesn't look like there's any other questions. And again, if anything comes up, I can answer those at the end of the webinar. So I'm going to go ahead and move on to the next topic today, which is how do I convert an image of a contour map to a grid and a contour map in Surfer. So I'm going to go ahead and open up a new project. Okay, so to start things off here, I wanted to make a quick note that the following workflow is only available to users that also have Surfer installed. The workflow I'm going to detail here is a great way to take information from an image map, whether that's a scan of a paper map or if it's already in digital format, and grid it in Surfer to generate any of Surfer's grid-based map types. Now, in order to save time today, I opened a project that contains a USGS quad contour map that I've already extracted a small section from, and I've already spent the time to digitize the contours that were visible in this map. So I've also already assigned the contour elevation values by using the map data assign elevations command. So as you can see, when I scroll up and down in the data manager, in the primary ID field, there are already elevation values listed for all these polylines. These values are what Surfer is going to use as the Z coordinate when generating the Surfer grid file or GRD file. So let's go ahead and take a look at these commands. To send this information over to Surfer, I'm going to click Map, Surfer, and the Grid Data option. As you can see, the Grid Data dialog is opened. For the gridding method, I'm going to use minimum curvature. But as you can see, there's also inverse distance to a power, nearest neighbor, radial basis, and triangulation. So I'm going to go ahead and click minimum curvature. So all the contours that I've digitized are located on layer 1 in my Didger project. So I'm going to click the layer radio button right here and make sure it's set to layer 1. Now I want to see a contour map in Surfer when this workflow is finished. So I'm going to go ahead and check Create Surfer Map, and then select the radio button for Contour Map. In the bottom part of this dialog, we can see where Surfer's grid file is going to be written to by taking a look at the file path. Now, if you want to send this grid and save the grid to a different location, any directory will work, and you can change directories by clicking the folder icon. Under the gridding options window, you can also see the mins and maxes and the numbers of rows and columns. So this is very similar to what you would see in Surfer's Grid Data Dialog. All these fields are, you can change anything here, so this can all be edited. I'm going to go ahead and stick with the default settings here, and as soon as I click OK, it's going to send this information, create the grid file, and open Surfer. So now that Surfer opens, you can see a nice contour map that looks very similar to what we saw in the Didger project. So this concludes this portion of the webinar. So I'm available to take any questions from the audience, so please send them over if you haven't already done so. Okay, my first question here is, how did I draw the contours in this map? I used the tool Draw Polyline and went ahead and traced and clicked on all the vertices of the line manually with my mouse. This image does have enough contrast that it was most likely a good candidate for the image, vectorize image command that we talked about earlier in the webinar today. I have another question. Can you save contours as XYZ instead of creating the grid file? Through the workflow specifically, no. The workflow I just detailed always creates a grid file. However, if I wanted to use file, I could export it. So if I wanted to select all the contours, actually this is what we do first, and use file export, and we could save to a DAT file, text file, any of the supported worksheet formats, and always use the selected objects only if you're selecting objects and trying to export them. So I'm going to go ahead and show you an example of this. I'll go ahead and open that file I just created, and as you can see, oh, wrong one, excuse me. Go ahead and open this file again for you here. And as you can see, all the elevation values are in the Z column, and the XY values are all the vertices that were along those polylines. I'm going to check with my host again to see if there are any more questions outstanding. Okay, it doesn't look like it. So I'm going to go ahead and move on to the final portion. So for the final portion, I would like to discuss editing vector objects that are part of shapefiles. So in this last demonstration, I'll be performing a few different editing tasks in Didger, like reshaping a polyline to better fit a high resolution image, and adding a new feature to a shapefile, and then finally editing the attribute information. So I'm going to go ahead and open up a new project here. So in this project, Didger project, I have a road shapefile that's overlaid on a high-res image, and there's an area within this image that I'd like to focus on. I'm going to go ahead and zoom in there right now. And as you can see, this road right here that I'm selecting does not really fit the underlying image, and it's not really good enough resolution for a small-scale mapping operation. So what I'm going to do is I'm going to reshape the polyline so it better fits the underlying aerial image. To do so with the polyline selected, and actually what I'm going to do real quick so we can see this a little better, I'm going to reduce the bitmap opacity a little bit, and again select the polyline and use draw reshape. Now as you can see, there's a number of different nodes along this polyline. What I can do with my mouse pointer at this point is I can drag these nodes around so they better fit on the underlying image. Any place that I need to add a node, I can do so by hitting the control button, and you can see my mouse pointer turn into a crosshair, and I can click along the line to add some nodes. And so I'm going to go ahead and drag these around just a little bit, and please bear with me while I get this done. So again, I'm using the control key to add some nodes here. Dragging everything to the appropriate spot. Okay, getting closer. When I'm done reshaping the polyline, I'm going to go ahead and hit enter to accept all these the reshape edits here. Now, as you can see, the road definitely fits this image a little bit better. And let's turn the opacity up just a little bit here so we can see this again. Okay, so now I'm going to go ahead and add a polyline. So we can see this little section of the road right here actually doesn't extend to the end of my aerial image. So I'm going to use the draw polyline command, and I'm going to go ahead and digitize a little segment of the road. As you can see, this road will now be added to the shapefile if I exported this out of Didger. So finally, I want to adjust the attribute values, or the attribute fields rather, for this roads file to remove the empty primary, secondary, tertiary, and quaternary fields. So if I were to export this file, those would not appear in the associated attribute table or DBF file. To do so, I'm going to use map, data, edit attribute fields. In the data attributes dialog, I'm going to make sure primary is selected and click the remove field button. Again, I'm going to do this for the other three fields. Now, Didger always requires you to have a primary ID field set. And so before clicking OK, I'm going to go ahead and set this to F node. I'm going to click OK. As you can see, those empty fields have been removed. So now I'm going to go ahead and open this up again for any remaining questions that anyone has. Okay, I have the first question coming in is, Can you add attribute fields to this file? Sure, absolutely. The same process can be used. Again, it's map, data, edit attribute fields. This time you can click an add field button and you can see a new field is entered. So if I was to, you could rename this anything. When I click OK, we can see that this new field right here has been added. Any of the attribute values you want to add can be added directly into the data manager by double-clicking in this field, or in the property manager under data attributes. Let's see right here. Okay, new field right here. We could enter this information. You can see this information was then added to the data manager and would be included in the associated attribute table or DBF file once this shapefile is exported. See, I have another question, it looks like. The question is, when you reshape the polyline, that worked great. Is the same command available for polygons? Great question, and absolutely. If we were to generate a polygon, let's say in the map like this, I could go ahead and select it. And let's change the fill pattern so you can see this, but the same command, draw reshape, would be available, and the same nodes are there, and we can reshape this polygon however we'd like. So yes, this command is available. Okay, I'm going to check with my host to see if there's any outstanding questions. Okay, it doesn't look like it. So that concludes my presentation of the Didger 5 More FAQs webinar. If you have any additional questions now that the webinar is concluded, you can call our technical support phone line or email any questions directly to me at drew@goldensoftware.com. And again, a recording of this webinar will be posted shortly on our website. And always, thank you very much for your time.